Welcome to qnawire.
Hi, so over here we're going to have the following situation in which a basketball player is going to shoot with the same initial velocity equal to 8.4 meters per second a ball, and what is going to occur is that with both shooting angles we're going to be able to hoop the ball. The height over here is going to be equal to 3.15 meters, so that means that the change on y from the point in which the ball was shot of 2.15 and the final point would be equal to 1 meter. With this information, and knowing that the initial velocity is equal to 8.4 meters per second, and the two angles that we're going to get are going to be respectively for theta 1 54.3135 degrees and 45 point, I think it says 1488.85. With this information we want to know what is going to be the distance on x. So over here, we're going to assume that the parabolic shot implies that the acceleration on y is going to be equal directly to minus g only, and we're going to consider that there's going to be no air resistance, so the acceleration on the x-axis is going to be equal to 0. So the equation of motion for delta y would be equal to initial velocity on y times t plus 1/2 of acceleration times t squared. For the case of x, we're going to have initial velocity on x times t. So over here, what we're going to have as well is that for each of the situations, the value for delta x needs to be the same. So what we're going to have is that delta x on shot 1 needs to be equal to delta x on shot 2. The same thing happens with delta y in shot 1 and delta y on shot 2. So from the first equation, the first condition, what we're going to have is that delta x, the x projection of velocity, is going to be equal to the initial velocity times the cosine of theta 1 times t needs to be equal to velocity times the cosine of theta 2 times t2 for the second shot. For the delta y equations, what we're going to have is that the velocity times the sine of theta 1 times t1 plus 1/2. Sorry, in this case, we could put directly minus g over 2 t1 squared needs to be equal to velocity times sine of theta 2. Remember, we're using sine because this is going to be the y projection times t2 minus g over 2 t1 squared. Sorry, t2 is squared. And both of them needs to be equal to delta y equal to 1 meter. So what we can do is solve for t1 and t2 from the equations on the delta y. We're going to have a quadratic expression in which we're going to get that g over 2 t1 squared minus b times sine of theta 1 t1 plus 1 meter, which corresponds to the value for delta y, is going to be equal to 0. And we're going to have the same quadratic expression for t2, but with the second angle. So the first equation is going to become 4.905 t1 squared minus initial velocity times the sine of the first angle, which is going to be 6.822656 times t1. Here I'm taking a lot of significant digits in order to get a very accurate result. Plus 1 is going to be equal to 0. And the second equation is going to be 4.905 t2 squared minus 5.95507 16 times t2 plus 1 equal to 0. So in this case, if the resolution of the image made me make a mistake on the angles that I provided, this is going to be where you're going to see the difference. You just need to do this calculation of velocity times sine of theta 1 and velocity times sine of theta 2. Okay? So with this, we're going to have two quadratic expressions that you can solve either using the general formula of minus b plus minus square root of b squared minus 4ac over 2a, or you can use your scientific calculator to get both of the results. So the first equation is going to provide the two solutions, t11 and t12, equal to 0.1665 seconds and 1.22446 seconds. So in this case, we're going to take the second solution because the first solution corresponds to the first section of the movement to getting up to this point of delta y. The second point is going to be later in time. So, and for the second equation, the only factor that is going to change is the value for b. So in this case, it's going to be equal to 5.9550716. And the two solutions that we're going to get are going to be, whoops, for some reason stopped writing. Okay, now it should appear. Okay, T21 and T22 equal to 0.213 seconds and 1.01278 seconds. So with this, again, we're going to take the second solution and we're going to get the values of T1 and T2. So T1 and T2 are going to correspond respectively to 1.22446 seconds and T2 equal to 1.01278 seconds. So with these two values, we can now go back to the equations coming from delta x, the values over here, and we can use either of them. So for example, we're going to find it first using the cosine of theta 1 times t1, and then we're going to do the same calculation with cosine of theta 2 times t2. So the first solution is going to give us exactly 6.00002 meters, and the second solution is going to give us 5.99999 meters. So with this, we can say that the value for delta x is going to be equal to 6 meters exactly. And with that, it would be all. Thank you very much and have a good one.